Hello and welcome back to the channel Understanding Concepts of Physics. Today we are starting with a new topic. We are starting with thermodynamics. As you can see on the screen, we have been doing kinetic theory of gases since past a few days, and I hope you have gone through those videos where we had discussed kinetic theory of gases. Definitely, if you wish to go into details of thermodynamics, I would request everyone to go and see the initial parts of kinetic theory of gases in case you haven't done so. So let's quickly begin with this topic. Now let me clarify this first itself. This topic is a lot of theoretical and most of it's conceptual. So you need to study a lot of definitions and yes, we have to understand a lot of things. So let's see. So thermodynamics, thermo means heat and dynamics means its flow. So the study of flow of heat. So if you are studying the flow of heat, how it is flowing from one point to another point, and also its interconversion with work. So whenever you heat something, definitely it may get converted to work, and this interconversion of how much energy is getting converted to work and how much is lost is what that study is called as thermodynamics. So thermodynamics is basically the flow of heat and its interconversion with work. So how it is going to convert with work and how much it is not. That's what we are about to study. Now, before we go into details of thermodynamics, I would say that you should be already knowing what temperature and heat is. So if you know what temperature is, how to convert from one unit system to another system of unit, then yes, definitely you will need those things in this particular chapter. Also, you should be knowing what heat is, how heat flows from higher temperature region to lower temperature region, and it can also backflow. This is done freely. Higher temperature region to lower temperature region is done freely. However, when you do lower temperature region to higher temperature region, we'll have to do some work. So this is what we have studied in the previous chapters, kinetic theory of gases, and you should be really going to study, go back to study the first, at least first 10 videos of KTG in order to understand this concepts of heat. So we are also studied about conduction, convection, and radiation. Okay, how heat radiates, how heat flows from one point to another point. So let's get quickly started, and there is a lot of definitions. So first we need to understand certain terms and terminologies, and if you can see on the screen, you have this first term which says thermodynamic system. So this is thermodynamic system. So when you are studying thermodynamics, we come across this word called a system many a times. So you may guess what the system is. So system is basically whatever you are trying to study. So whenever you are trying to study a particular body, that body becomes a system. So suppose if I have this container and I'm just having some liquid in this, and if I'm heating this container, obviously the substance which I have kept will heat up. So now because I am studying the heating of this liquid, this liquid becomes our system. So this becomes our system, and the surrounding, like the outside part of the system, anything outside system is what is called as the surrounding, and system and surrounding together is called as the universe. So if you see any part of the universe, so universe is basically system plus surrounding. So any part of the universe which is under study, so whatever we are studying, that part of the universe is called as the thermodynamic system. So why is it called as thermodynamic system? Because we are trying to understand the heat flow and the amount of work done, conversion of work done. That's why it is called as thermodynamic system. Surrounding is just opposite of that, any part of the universe other than the system. So leaving the system, everything else becomes the surrounding. So in a kitchen, if you are heating water, the water becomes our system, and rest everything becomes the surrounding. The kitchen becomes the surrounding, and rest everything becomes the surrounding. And universe is basically system and surrounding together are called as universe. So it's pretty simple. So these are the three definitions. In case you have not taken a screenshot, you can just go and take the screenshot of this in order to make a make notes. Now next we come to something called as internal energy. So if you can see on the screen, internal energy is basically the total energy of all atoms and molecules, of a system. So suppose if I have this system in which we have a particular gas, so these are the molecules which I have drawn, and the total energy of these molecules is what is called as the internal energy, and internal energy is written as U. So internal energy is basically the all the total energy of the atoms and molecules possessed. So this is an internal energy, and if you see that, okay, if we have a container of something which is at rest, this container is at rest and placed on a table, so its kinetic energy is zero, but the molecules are continuously in a random state of motion. Molecules are continuously moving, so it will be having some kinetic energy. So all the kinetic energy and the potential energy included is what is called as the internal energy of a system. Now potential energy in case of gases is pretty low, or we can just neglect it, but in case of liquids and gases, definitely we'll have to consider potential energy. um, Next comes the system. Okay, so system, we have understood what system is. Now we are coming to what is types of systems. So we have three types of systems. Let's go one by one. So the first system, which is called as the open system. Open system is very simple. Like if you heat a container of water in open, so it can exchange heat, as well as matter. So heat is also exchanged and matter is also exchanged. Such kind of system is called as an open system, in which heat and matter both are exchanged, is called as an open system. So a system in which energy as well as matter are exchanged is called as an open system. Heating H2O in water in open container is called as an open system. Now let's see closed system. So closed system is basically in which the matter is not exchanged, but the heat is exchanged. So a system in which only energy is exchanged but not the matter is called as a closed system. Okay, so heating water in closed container. So if I have this container and I have closed the lid on the container, and let's say this is some water, this is the lid. Okay, I have placed a lid. Okay, it's not open to air, and if I am heating this, then what is going to happen is, okay, the matter is not escaping, but the heat can escape from the walls of the container. So if this is the walls and if the heat is escaping from here, so and the matter is not exchanged because it's a closed container, so matter is all stayed in this particular region. So such kind of system is called as the closed system. And why is it called a closed system? Because matter is not exchanged but energy is exchanged. So a system in which only energy is exchanged but not the matter is called as a closed system. Now we come to next, which is called as isolated system. Now isolated system, what is this? Let's see. A system in which neither energy isolated, it's basically isolated from the surrounding, so neither energy nor matter exchanged. Such kind of system is called as a isolated system. So a system in which neither energy nor matter is exchanged is called as an isolated system. So example is a thermos flask. So if you have a thermos bottle, something like this, and if you have closed the cap of the thermos bottle, then matter does not escape, neither is heat escaped, because the thermos will have an insulation on the walls of the thermos bottle. So neither heat is exchanged nor matter is exchanged, so we can say thermos flask will be an isolated system. Now you should understand that there is nothing called as ideally isolated system, because even if it is a thermos flask bottle, after a very long period, then you will find out that, okay, it is going to cool, it is going to lose heat. So there is no perfect system. Okay, but yes, if you are able to isolate it from the surrounding for a small duration, then for the small duration the system would be called as an isolated system. So these are the three kinds of system. So we have done a few questions and topics, and let's let's quickly go on to one small law, which is what is called as the zeroth law. Or maybe I'll do this in one of my coming videos. In case you haven't not subscribed my channel yet, I would suggest you subscribe the channel and keep following the videos line by line. You will follow up a lot of things. Only thing is that if you jump from one video to another video and do not watch the entire video, you might find out the following video is much difficult. So watch the complete video, watch it till the end, watch in a series one by one, and you will definitely follow a lot of things. Thank you so much. Bye.